the so-called ticking time bomb. Everybody knows of the examples, and if you don't, then you should, of somebody recently told me there was one programmer who developed open source software who became a communist and said, well, you can't use this software commercially anymore. And all of a sudden, a lot of software that was depending on this piece of technology can't be used commercially, so that has to be rebuilt. Or the famous Log4j issue of a couple of months ago that all of a sudden popped up. This is something that is happening every day. And it's something that will happen tomorrow again, and the week after. Now, if something literally happens tomorrow, that is by coincidence. Let me say this. And this is something that we need to be aware of. And the interesting thing is, as Michiel will show you in a minute, that we can know this up front. Now, all the methods that we have that people are using to prevent issues from happening is to implement systems that look at, once it goes wrong, to be as quickly as possible to say, oh, there's a problem, you need to fix it immediately. That is after the fact. You need to be as much as possible before the fact. Try to prevent these issues from happening. And as Michiel will show you, there are certainly possibilities there.
Yes. Let me start by showing this rather complicated looking graph. But I will plot this line in here just for reference. This should not be here. This lump here indicates that most of the open source packages that are in use by our clients, this is data based on 1,000 client systems of us, are updated. This is the time scale, mostly after a year, or even 5 years is there. This lump should actually be moved, and a healthy situation should go that direction, and software that is being used should be updated when newer versions become available. Typically, there are good reasons such versions become available, like security problems, fixes for some kind of error, or other reasons. So this is the sort of the distribution we expected when we started looking at this data. This is coming from the open source health module that we have in SIG that tracks for our clients what open source packages they are using, what version, and whether there are any known problems with those. So we started looking at that, and we're actually shocked to see this. This is not what we expected. We really thought, okay, people really make a good effort and have a rational process here going on that prevents this. So most open source is updated in years rather than in days. And another realization for if you don't know, because these problems that Luc mentioned are not happening just because smart hackers find out ways to do it. These problems exist in these packages. And maybe 1 in 10 packages that are currently in use actually have known vulnerability problems, yet they are still in use, and they're still being used and downloaded by people. Actually, 40% of downloads of the Log4j example that Luc mentioned are still vulnerable versions. So people don't update their code. While it's actually, in many cases, not so hard to do. It can be as simple as updating a number, and then a new version will be applied. If you have proper testing, that can easily be done. In some cases, it's a lot more work, but it's almost always worth it to fix security problems that otherwise can be exploited. We're going to drill down a little bit this data, how it, what could be the reasons and what could be potential ways to fix. One of the things we looked at, and this is a very similar graph, here's again the time it takes to update something, and this is the chance that it has happened. So we're tracking here about 150,000 library versions that our clients were using in the past year, and there we have two classes, two lines. So the bottom one is for libraries that are sort of kept in the source code without any automated management. This can still be done. You can just copy in some code and keep it there and use it. That's the unmanaged part. This is the managed line, the blue one, which is sort of using a package manager or automated tool to handle your libraries. That's what you obviously should do, because it's typically 2 times faster. So those libraries that are managed automatically are 2 times faster. This practice is still pretty common, that people do it in an unmanaged way. Sometimes even IDEs, so development environments, make this happen. You should really become aware of it. In many cases, you can actually extract this information very easily from a tool. Open Source Health also tells you, and replace this with proper management tooling. Another reason that we thought up front it might matter how big the security issues are. If it's a very critical problem, or if it's a very it's sort of a medium risk problem, that might make a difference. So people that become aware of a critical issue, they might want to update faster. Well, again, we have a time to update graph here, and we see that it hardly matters, much to our surprise. So whether it's critical, which is the purple line, you don't even see it because they overlap so much, or if it's a low severity problem, the time to update doesn't really change. So developers are either not so much aware of the severity of problems, or they're not equipped, maybe, they're not allowed, maybe, to update their libraries quickly. There can be many underlying reasons. The effect is that 70% of those libraries are still in use, even if they're vulnerable to a critical problem. That doesn't sound good. In all these cases, security fixes are available because these known security vulnerability reports are published after a fix is made available in the sort of the ecosystem. So it's always possible to update. It might be a bit of work, but if it's a critical vulnerability, that's always what you should do. Then another one that is pretty close to our other service where we measure the quality of software itself, the software of the quality of a system really determines whether you can actually change that system, right? If you have a very badly written piece of code, it's hard to do anything with it. The same happens to be the case for this updating frequency. So here again, the same sort of plot, and we have 3 lines, one for the 2-star systems in our benchmark, the 3 stars, and the 4 stars. So obviously, 4-star code correlates with faster updates. It's faster, it still only gets to 40% here, right? So 60% still doesn't update fast. But at least with higher quality, you tend to update faster. So very obviously that is what you should aim for. This is not new advice from us, right? It's what we always say. There are many reasons why you should do this to be cost efficient, but updating is part of that, right? This is part of maintenance, something you should do. A bit of a different finding, but I would say the most important one from our report this year. And in the benchmark report, we describe in detail how we got here. We had the intuition that the quality of code, right, as I was telling about systems before, also applies to the libraries, right? So it doesn't matter what the quality of a library is compared to if they're vulnerable or not, right? So you would expect bad code has a higher chance, a higher risk of having vulnerabilities in it. Well, that is what we tested, and you see the result here. And it's an important result because the difference is quite big. In the middle, we have 3-star systems, about 3,500 of them. And, sorry, I have to say libraries. These are open source libraries that we've measured. We apply the same tooling we normally do on systems to the libraries. And we checked if they have a vulnerability. Then we compare the risk to the 4 stars systems that are obviously a little bit lower. But at the 2 stars, the risk is almost 2 times as high as in 4 stars. That's the major finding. Meaning, not only your own code matters, the quality of your own code, basically whatever you use, whatever you pull in from the open source world, really determines whether you will be at risk from, for example, security problems. This is a rather new thing because there's no tooling or platform available at the moment that really shows you the library build quality of all the things you use. Well, we have something to reveal. Yes. This is where I hand it over.
Yes, so maybe this is a good moment for the audience to phone the development teams and if you want 5 minutes break to inform how are we doing things, are we indeed managing things through package managers, how are we dealing with the update frequencies? Are we really this bad, or is this just an anomaly? Well, this is the data that we have collected over many years. This is not an anomaly. This is the fact of the matter. So we were actually shocked by these results. We were expecting some findings, but these are way more extreme. Of course, as a supplier of these kind of services, it's nice to have something impressive to say, but as a fighter for a healthier digital world, we'd rather see something else. This is not something that we were expecting, and it's really something we would like to draw your attention to. So try to automate this process much more than you do today. Have a look at this this process, have a look at this library, and be sure that you understand that bringing in something like Log4j is sort of an accident waiting to happen. Because if you look at the build quality of Log4j, it's actually quite bad. It has a very low quality. So you could have expected, and this is something that happens today in development teams, obviously, because there's not like a management team that should be deciding on which libraries that should be using, but there needs to be awareness of that kind of relationship. And that's something we really like to draw your attention to.